No! Word problems. Word problems. Okay, word problems are no big deal, especially these ones. You don't have to actually solve them all the way out. You just have to be able to write the equation that it is talking about. So let's point out the variables and the math words and write what we need to write. Okay, so habitat of prairie dogs can support M dogs. Okay, that's important to know. M represents number of dogs. The habitat's population is P. So P is habitat's population. We'll go ahead and circle that. It grows proportionally. Okay, so we have two things happening here. We have proportionally is a math word, product is a math word, and difference is a math word. When you see the word proportionally, you guys should think a number equals K times a number. All right, the K is what we call the constant of proportionality. And all that means is it relates, let's say X and Y. And if I told you that X was 6 and Y was 12, then you, oh wait, not 12, let's do 3. Or 2, yeah, that doesn't matter, then that means that K would have to be 3 in this case. Okay, 3 would be the constant of proportionality. All right, let me delete all that extra stuff. This is what you're thinking when you see proportionality. All right, so it's saying that we're growing, which means that P has a rate of change. Okay, so dP dt. It doesn't specify what P is growing with respect to. So we're just going to assume it's with respect to T. Sometimes these problems say with respect to, and they're like, let's say it said with respect to the number of dogs. Then you wouldn't have a T here, you would have an M. Okay, but it doesn't say with respect to anything, so we're going to assume that it's time. And it says it grows proportionally to the product. So the dP dt is this guy. And that means on the other side, we're going to have a constant of proportionality multiplying to something. What is it going to be multiplying to? I'm pretty sure I'm going to need brackets on this, or maybe just parentheses. But let's read the rest of it. It grows proportionally to the product. So two things multiplying to each other, to the product of the current population, which was P, and the difference between M and P. Okay, so that's pretty self-explanatory. The difference between M and P, and we have to go in order, M minus P, because that's how they said it. They said M and P. But now, what is the current population? The habitat prairie dogs can be supported as M dogs at most. The habitat's population is P. So we're going to have to go with P as the habitat's population. So there you have it. You have the product of P and the difference of M and P. Therefore, it looks like this guy right here is our answer. All right, let's read another one just to keep practicing here. We have an amount Z of a chemical. So Z is the chemical in the tank. It says it decreases at a rate proportional to. So because it says decreases, our what is it called? The constant of proportionality is going to be negative. So we have decreases is a math word. Proportional, we have that word proportional again. So we have K times something, and it's going to be a negative K because it's decreasing. And then we have Z is one of the variables, which I already circled. I circled earlier. I just repeated myself. But anyways, it says proportional to Z. So it says that we're decreasing the rate of this guy is decreasing at a rate that's proportional to its to Z, okay, to the amount, which we know is an exponential relationship. And, okay, this is kind of weird, and inversely proportional. Okay, that's another math word there. And what that means is that this guy is going to be all under, it says the volume of the solution of the tank. Now, it looks like I accidentally cut off part of this problem, which means I'm going to make another video for this. But whatever this volume of the solution of the tank is, which I can't see what it is, it's defined. I'm assuming it's going to be 20 plus 2t because that's what I see down there. But I'm just going to write V right here. So the rate would be proportional to that and inversely proportional to that. Whenever you see the word inversely proportional, that means that number, whatever it's talking about, in this case it's talking about volume, is going to divide the constant of proportionality. Okay, this is kind of a crazy one because it uses proportional and inversely proportional.